demonetized. We weren't monetized in the first place. Can't get demonetized. Okay, awesome. We're back. Sorry about the late start. So these in-person meetings are going to be live Q&As on the lectures that are on YouTube and on of course, the challenges that you're all tackling. I'll try to be as helpful as possible without just straight up giving out answers in most cases, but in some cases, I'm going to be giving out answers like today. We're going to do a speed run through the first couple of challenges, just kind of to get things rolling. Okay, and again, we're live both on Twitch and live. We have a couple of students that can't show up due to being quarantined, and then are presumably adoring fans all over the world. So let's talk about the state of the class week 2. We haven't had a deadline yet for any homework, so there's not much data to present. What we can say is we are moving ahead. We're still on schedule. We'd be in trouble if we were already off schedule this early, right? But still going strong. The helper extra credit, big shout out to Connor for being the most helpful person on Discord. 18 thanks, and of course the others are what you'd expect from seeing people that are helping each other so far. Seems to be working well. We've removed the cooldown on the rep bot just to facilitate thanking multiple people when you're being helped by multiple people. The rep bot does not allow for multiple things at the same time. It's not a big deal. All right. So far, no abuse of this system, which we were slightly worried about initially. Everything looks good. Thank you for helping each other. It makes for a kinder, gentler pwn.college that hopefully will be more successful to more people. All right. Last week in CTF, we had 7 students submit write-ups. Those 7 students were spread across 2 teams. One was, I had to memorize. One was, what's the character limit for this website? And the other one was something about a flag. Something. All right, something about the flag. Good job, great start. That's the first CTF. A lot of you were jumping on this with really no prior experience, and each team solved at least one non-sanity check challenge. That was awesome. It's a great start. So we're gonna go back through and approve all of the write-ups. The write-ups, of course, are now being handled not over email, but over this awesome page that Connor wrote. We will go approve those. I sent some people feedback already. Take that feedback to heart. Generally speaking, if there isn't enough detail, say, okay, in this one, there's not enough detail, please do better next week. And then next week, we'll actually check more closely and make sure that you're taking that to heart. All right, what are the CTFs this weekend? There are 4 CTFs going on. There are actually 5, but one of them is the final event, for which the qualifier event was a couple months ago. So there are 4 functionally open CTFs going on, 3 Jeopardy style, 1 attack defense. What does that mean? Jeopardy style is what you're kind of used to on the homeworks now. You go and you select a problem, you work on it, you solve it, you get a flag, you submit a flag. Attack defense is a little different. It's a very interesting, it's actually the more original kind of hacking competition, where there are multiple teams, they're all running vulnerable infrastructure and they hack each other, right? So the challenge problems are something that you have to attack and defend. It's a bit more involved, but hopefully this one is more introductory. So I don't know, if you want to tackle that, you can go ahead and give it a try. It'll be a bit of a trial by fire. Otherwise, there's 3 great CTFs to choose from. For what it's worth, it looks like Shellfish is playing F-word CTF. But the other two look great as well. All right, so again, if you want that 1 point to your final grade extra credit, you need teams of at least 4 or at most 8, or if you have an existing team, let me know and I will approve it or not, depending on that. Well, no, I mean, most likely it's okay. I just have this rule so I can go and verify that you are actually doing individual hacking, or you're contributing to the team as you're doing CTFs. Make a write-up, like 2 pages, talk about what you tried, what worked, what didn't work, what you learned, et cetera, put in screenshots to fluff it out, whatever you want, and then upload the PDF to that website. All right. Oh, man. All right, now I have the scene sharing the screen. Sorry about that. You didn't miss any critical information yet. All right, we're also launching at 5:30. After we talk about program interaction, we're launching the program misuse module. This is a light warm-up module, again, like program interaction, that explores some of the concepts around misusing programs to get flags. It's gonna look exactly the same. You choose a level, there'll be a challenge in /challenge/baby suid level X, and then it'll set the suid bit on a specific program, such as user bin cat, and then you'll try to leak the flag using that program. The most useful thing about this is man pages. This is a thinly veiled attempts to force you to learn a lot of Linux utilities, right? But also to start reasoning about how to misuse them. For one of the levels, at least, you'll have to compile a library. That'll be fun. And then figure out how to run code at loading time of the library. All right, there's 51 challenges, along with the program interaction module. It's due on the 31st, that is 1 week from now. We're going to change one thing. The embryo IO, the interaction module, is a little beefier than originally envisioned. So we're going to slacken the late credit for that one a little bit. If you submit it after it's due, you'll get 75% credit instead of 50% credit per flag. Hopefully that will reduce stress a little bit, leave more kind of credit redeemable afterwards. Cool. All right. Any questions on that?
I don't think it's if you like multiple CTFs, you can separate submit separate for each one.
So there's a question: if you did multiple CTFs in a weekend, can you submit write-ups for each one? Squish them into one PDF, but you'll still get only 1% credit per weekend. Yeah, there's 1% per weekend up for grabs. If you're doing multiple CTFs a weekend, you likely ace this class anyways. Other questions? Yes. Oh shit. I keep mistyping baby shell as baby suet. Sorry about that. Let me see if I can fix it live. One sec. That's going to cause confusion. Yeah, baby shell, we're not going to, hoist that on you. So suddenly, that would be pretty good. Baby shell's actually due tomorrow. That's a joke. Sorry? It's showing me what? Oh, that's fine. Good. All right. Awesome. Okay. So, baby Suid is due next week. Embryo IO is due next week. And if you do embryo IO late, you still get 75% of that credit instead of 50%. All right. My default idea for what to do on this class is I was going to speed run through embryo IO and answer any question along the way. Are there any questions to answer in general? Nobody? Go ahead and yell if I don't see you. Anybody on Twitch? All right, everyone is racing with baby Suid, I guess. Or sorry, with embryo IO. All right. Any other requests other than running through embryo IO? Cool. Let's do it. All right, so here's pwn.college. We go to, whoops, the challenges, program interaction. I solved level 1 in class last time. Level 1 is just like, you know, can you, I'll zoom out, can you run the program? Turns out I can run the program. So let's keep digging in. So a couple of things I'll point out. I guess every year we forget to make a write-up or video on how to use the infrastructure. A couple of things that people might not have realized. Starts the challenge. You can spin up, you know, go to your workspace, spin up a terminal. All is good. Practice, start up the challenge and gives you administrative access, but with a fake flag. This is very good for debugging. So if I click here, it says challenge started. I go to the workspace. Okay, the workspace loads. All right, so here's level 2 in practice mode. You can tell because it says practice. That's a new feature. There's a couple of things that happen. Of course, can't read the flag because it is read only by root, but I can sudo. So now I'm root. Now I can trivially read the flag, but the flag is a practice flag. All right. Can I make the font bigger? Oh man. Are you joking, man? This literally cost me 3 hours of my life. Oh my God. What you all missed is me like having practically a midlife crisis over trying to set this freaking font. Okay, let's see. Is this okay? Yeah, we're fine. All right. So root access in practice mode. This is kind of nice even right now to debug how your you know, pipes and stuff look in the process that you're trying to run by like looking at, you know, proc process ID fd, and so PID 1 of this container, which is Docker init, and as you've all probably experienced, has standard in, out, and error open to the what's it called, the terminal. But in later levels, this will become critical for debugging and so forth. So just letting you know, practice mode exists and is a great way to practice before seeing before actually trying your solution on the real challenge with the real flag. But let's hit it up in normal mode. All right. Here we go. Oh, wait, I just there. Go back to the workspace. All right. Let's launch it. It says, okay, I need to pass the checks on the parent process. Who is the shell? Reading in my input now. I need a simple password. All right, this one is easy. All right, here's the flag. That was very easy. A little too easy. Okay. We go back to the challenges. Submit that. Actually, let me also show you how to set up SSH. Did we show them how to set up SSH? For real? Okay, very briefly. So I'm going to show you how to set up SSH so I don't have to keep switching back and forth. So here I am in a directory I have just for pwn.college. I'm going to create a SSH key. No password. Passwords are for very, very paranoid people. So you can cat out the public key. All right. That's my stage key. I go into profile, settings, SSH key, paste that in, update. Great. Let's now, I can use that SSH key to SSH into dojo.pwn.college. You want to username hacker. You can do a -v just to make sure things are happening. And okay, here we go. So now we're here on the terminal. When we launch new things, it should now auto drop us in, right? So level 3, launch level 3. Actually, let's catch up on Twitch. Just mostly seems to be shit posting. Okay, good. Any questions in real life? Awesome. Okay. Here is challenge 3. What's it asking me to do? argv1 should have a value of something, and then it crashes. That's unfortunate. I must have introduced that last minute. Can you make a note for me to fix this? It should nicely tell you that you don't have an argv1. But if I put that in argv1, boom, good to go. All right. Now we're rolling. Level 4. Launch it up. Okay, what's it telling us? I passed the checks on the parent process. Now I need to have this variable set to that. So I do this, this. Level 4, done. Okay. Now we're getting really amped, right? Speed run. All right, we start this one. All right. So, actually, it must be bash. We should have redirected a file called this to my Stdn. So I will touch this file and I'll run the checker with this file. And it wants a simple password. So now I need to put that password in. All right. There we go. Now we have this flag. Any questions on any of that so far? No? All good? All good. All right. Start level 6. All right, the last test I failed. I haven't redirected anything for this process std out. It says I want to redirect that from the std out. So I just do this. Std out redirection in the shell as described in a lot of the in the lecture and a lot of the reading materials. And of course, that redirects all the output to this file, and we can submit that here. All right, now we're on level 7. All right, it wants me to run this with an empty environment. And so here is the first kind of tricky one. How do we create an empty environment? Well, we can unset manually in bash each of these environment variables. There aren't very many, but we'll find, so I can unset Debian front end, for example. Okay, that's gone. I can unset else, well, let's unset something less painful. Challenge ID, that's gone. If I try to unset the underscore variable, it's back. Right? Underscore variable will never leave us while we're in this session. So we need to figure out how to have bash execute something and keep its environment blank. There are two ways, well, there are many, many ways. The two most common ones is the end command that I've been using to list my environment. Also allows you to, if you do man end or end dash dash help, to say dash I, ignore the environment, starts with an empty environment. So we do end dash I slash boom, success, empty environment. All right, there's another way. And with the command, there's also the exec built in, which can do something similar. Exec-c executes the command with an empty environment. Now, exec will replace my shell process altogether. What I want to do is launch sh. Now I have a child of my shell that is sh. I can do exec-c slash challenge. Sorry. Okay, we'll just do another bash. I guess -c is an extension to bash. Boom. Now that subshell is gone, and I have my main shell back. And here is the flag. All right, two ways. Let me show you a third. Okay, and this is going to be very useful later on, especially when we get into argv. Recall that the exec ve system call replaces the process that calls exec v with the new process that it launches. So do exec v.c. I think it's there. If we do man exec, here's a nice way, different ways to call exec ve is not a library function, it is a system call, so it has its own man page. I give it a path name, I give it the argument, and I give it the environment. Nice and easy. All right. So, and if I pass null to any of these, it'll null out either the argument or the environment. How do we give it a null argument then? Exec v. Okay, this is our argument to this program. And then we can say, okay, just give it argv0. And then we can initially give it, well, let's just cut to the chase. This will run programs with both a null environment and a null argv. You should understand why this happens. So this is a bit of a freebie in this case. If you don't, we compile this. Okay, we run it on the challenge. What's going on? Oh, oops, I did argv 0 instead of argv 1. There it is. We launched it with an empty environment. What we actually launched was this execv program I wrote. But when it checks its parent, because execv calls execv and replaces itself with the challenge, when it does these parent process checks, it parent is bash, and all is good. Okay. Awesome. So that's another flag. All right, level 8. Here we go. Level 8 starts repeating that cycle, but now everything needs to be its own shell script, right? So I need to execute as the parent of the challenge something that does bash, and then any script ending in .sh. So let's do it. So now we're going to let's set up an easier screen session. Okay, let me copy in my screen RC in there. It's the only way to fly. All right, now I can SH back in. All right, oh no. This, we need to, why is, okay, all right. Cool. Oh, but this is gonna get killed every time I restart anything. All right, anyways, we're going to edit. Oh, I like that a lot better. Thank you. Here's my stage command. I'll do the screen on the outside. All right. Here we go. What do we do? Let's run this. Of course, it tells us no good. So we're gonna edit x.sh. And we'll need to just execute this script. And we can run it this way. And we have the flag, done. Okay. Submit that. Level 9. And we repeat this theme, right? So we try to execute it, or let's actually execute our, oh, we don't have our, okay, here is, all right, so now we need to interact with it. You know, now that I am speed running these, I can see the criticism of it being a little repetitive. I think you guys are right. We'll trim down some of those levels. Level 10. Okay, we need to give it a value. argv1 of this. All right, here we go. I just want to get to Python. All right. Level 11. Okay, variables. Here we go. All right, level 12. All right. So this guy wants this redirected. First, we touch this file. All right, perfect. Oh, and enter a password. All right. $13. Is the output. Oops, that's my old file that I created again for no reason. All right. $14. Oops. All right, launch the program with zero environment variables. We know how to do this now. Now I'm going to do this, and what is going to happen is that it won't work. Why? It says the shell process must be executing a shell script that you wrote like this, bash myscript.sh or anything.sh. But that's what I did. Up here, I ran bash x.sh. What happened? Someone here knows. Yes. Exactly. Exec replaced the bash that was running this script with the challenge. Now that challenge's parent was my interactive shell. It's no good. Couple of things we can do. We can do m-i instead. This will work for sure. Or we can do some crazy stuff and do this. Bash-c says run that command in a subshell. There are other ways to make subshells. For example, this creates a subshell. Boom. So what happened here is we created a subshell. Inside that subshell, we executed the exec-c, and then all is good. A little bit of a bash magic for you guys. It's good stuff. I used to do, when I started my PhD, Bash was my primary programming language. I did everything in Bash. I did research projects in Bash. I wrote a distributed consensus system. Anyone heard of the Paxos algorithm? It's a big thing in distributed insanity. And I wrote that in Bash. It was crazy. And the creator of Bash, Brian Fox, remember? Anyways, the creator of Bash came to UC Santa Barbara. I was doing my PhD and gave a talk. And so I ran up to him. I'm a huge fan. I do all of my programming in Bash. And he looks at me and says, why? So yeah, Bash is awesome. Did we solve level 14? Yes, okay. Level 15. Wait, what happened to level 11? Oh, really? I'm a massive noob. All right, anyway, that's fine. Level 15. Okay. What happens here? Yes, finally. Executable must be Python. All right. Yes, yes. Who here loves Python? All right. Should get some more hands. Python is the ultimate programming language other than x86 assembly. If you have to write something, write an x86 assembly. If you ever played Roller Coaster Tycoon. Who's played Roller Coaster Tycoon? That's right. That's a lot more hands than people that love Python. You know why? Because Roller Coaster Tycoon 1 and 2 were written in x86 assembly, handcrafted x86 assembly. So was Transport Tycoon, another excellent game, by the way. Yeah, because Chris Sawyer is a crazy person. It's like writing a game in Bash, but obviously it makes a lot more sense. Anyways, x86 assembly is the ultimate programming language. Right next to it is Python, all right? Python will get you through everything you need to do in this class from a programmatic perspective, interacting with programs, programmatic debugging, file system operation, automatically submitting, I don't know, whatever you want to do with it. It's awesome stuff. So this forces you to at least run Python, right? So now we can say, what are we testing here? We are testing the parent process as an interactive IPython instance. Now, what I didn't realize is, of course, you can run stuff in IPython using, I guess, yeah, that's a bad news. So we could try to run this directly out of IPython, which wasn't the intention behind here, but of course, you all found a way, which is great. Okay, boom. What happened? Well, Python launches a shell which launches the process, right? Similar to os.system, similar to, or system in C, similar to a lot of stuff. But of course, we know what we can do. We can do this, or well, just that works. Or there's other Python, IPython trickery, and that wasn't the point of this at all. The point of this was to let you write and interact with things, import subprocess or pwn tools, and subprocess.popen, challenges, embryo, IO level 15. What? Ah, fuck. All right, and it works, right? And later on, we want to train how to redirect input. And later on, we want to train how to do all sorts of stuff. But I didn't quite hit the bar on making sure these things can't be cheesed, but that's okay. Because later levels force you to do the right thing anyways, just through sheer complexity. It's just that makes the difficulty curve a little weirder than expected. All right, so here is the kind of right way to do it. The even more right way that you'll recognize is say, okay, let's put standard out and standard there, or sorry, and standard in as pipes. Here it is, and then we do read standard out, and we can write to standard there and interact with the program, and it is all very awesome. All right, so that's subprocess. Pwn tools. So who's team subprocess? All right, who's team pwn tools? All right, pwn tools doesn't have a lot of support yet, but pwn tools will become your best friend over the course of this class, because pwn tools is created for interacting with these programs from a security standpoint, making it easy to shunt binary data in and out, making it easy to run programs directly and then switch to connecting remotely, making it easy to launch programs in a debugger and interact with them. But that's fine for now. We have subprocess. Let me just show you how easy pwn tools is. Almost a drop-in replacement for subprocess when doing this, except for instead of a weirdly named popen, we do pwn.process, and then we do pwn.pipe here. pwn.pipe here. And we just do p.read. Nice and easy. All right, cool. So have that. Team sub process on Twitch. All right. Cool. So level 16. Let's take a look at what this brings us. All right, executable must be Python. And of course, it's because we're checking that we're normalized Python. Then we're going to launch this from IPython. Oops. All right. Here's a nice thing. We can start building up a whole script. That was me hitting Control O. The amazing thing about IPython, why I love using it, you can just write up whole Python scripts in your terminal, execute them, and then later on, you can save them to a file and run them in Python. This was kind of the intended idea here, but I guess we didn't quite hit the mark there. All right. And of course, since we have all of Python at our disposal, we can do something very cool. Use the glob module to say challenge slash, and this will grab whichever challenge, just like on the shell, and run it. And now we can print out p.read. Now this is a byte string. You should look up what a byte string is in Python. Hopefully you're all very familiar with this concept now. And in order to print it out reasonably, we want to decode it into a normal string, and boom. All right. So now it wants to read in our input over standard in. No problem. Oops, sorry. I keep trying to use my Vim bindings. Who uses Vim bindings in IPython? IPython supports Vim bindings. You can do JKL semicolon and seek up, right, left, and so forth. But I haven't gotten around to configuring this instance of pwn.college to it yet. But that's okay. All right, so we can do p.write. And we send it this. Oops, and I should actually do send line. One nice thing about subprocess versus, sorry, pwn.tools versus subprocess, pwn.tools has a lot of these little convenience functions, like, hey, send this and then a new line, right? All right, there we go. We have satisfied that check. Level 17. All right. Oh no, hopefully my Python history is back. Yeah. Okay, so we run this and says, nope, argv1 needs to have a value. Okay, that's okay. I just realized, what is I'm running out of batteries. Phew. Oh, okay. Recharging. Okay, awesome. So we need a argument of this. Okay, boom, done. All right, start this one. Oops, God damn it. Hold on, let me just set that. There, okay. Now when I hit up, it'll go back into IPython where everything should be. All right. You know, I did briefly consider changing my actual shell to IPython. You can do that. You can change your shell to something called conch. Spelled XONSH. CSH? I don't remember. It's insane. It's like a blend of Python and Bash. Imagine the warmth you feel when using Python and using Bash. The only thing better is a shell in x86 assembly. Imagine that. Just move, push, pop, syscall, and then your command executes. That would be great. All right, awesome. Anyways, environment variables in Python. So it's very easy. We just say n equals this colon this. All right. Boom, done. All right, just a little more pain and we can get to the piping. That's where the fun stuff starts. Okay, level 19, challenge successfully started. We run this, it says standard in. So we need this file to standard in, no problem. Say with open this file, right, as O. So this is a very cool Pythonism that, well, we don't know what to write in here yet. All right, so we have a file that we have now created. How do we actually redirect this file? This creates the file, writes ASDF into it. How do we redirect it to our process? Well, instead of pwn.pipe, we give it an open file. Boom. All right, it read ASDF from it, but it needs to be new up. So we'll do that. Boom. What? With a new line, maybe? No, that doesn't make sense. Oh yeah, with a new line. Okay. It uses input. Yeah, we should fix that. All right, anyways, cool. Got that flag. So now we're starting to get into real deal stuff, redirecting files into Stdn. All right, let's run level 20. This one needs std out redirected to that. That's nice and easy. Let's delete this. What the hell is going on? Man, Emacs mode is awful. Why don't we have Vim mode by default in life? All right, we have this. Nothing for Stdn. Oh, no, something for Stdn. Yeah, nothing for Stdn. Okay, we run it. Oh, no. And now we start running into pwn tools bugs. Let's just not do that. All right, so we have standard output redirected. We hit enter. All right, we can actually read this guy. Let's see what happens now. There it is. Our flag. Amazing. All right, level 21. Let's see what happens. Let's take this back out. And then back out. And this guy back out. What does level 21 want from us? What? Oh, pwn tools by default sets up the pipes, right? So now we need to read from that process. Or pwn tools gives you a very nice p.interactive, which drops you into the processes standard in, standard out, and it's very awesome. All right, blank environment. Of course, we already saw how to set environment variables. What we actually did with that command was set a single environment variable. So we just set 0. And here it is. All right, level 22. Now we need to run everything we just did, but in actual Python script. But if you notice, I already wrote Python script. I just did it in IPython. And in fact, it is all hidden in my history. God damn it. There we go. The IPython way to ask it for help here. All right, I can dig it all out of my history from previous sessions and so forth. I can hit up and go that way, or because you guys probably don't want to sit here and watch me go through another 7 levels of the same thing, we're going to jump ahead so that we can get to the shell, sorry, to the C stuff. So let's see, is this still, anyone know the first C level? 30, all right, it was too off. So we're gonna skip to level 30. Imagine that we did all the same thing. You notice I was using fully valid Python the whole time in IPython. Excuse me, if you're not using fully valid Python in IPython, that doesn't make you a bad person. Let's say it's on that, on the journey, you know? As they say, the road to hell is paved with invalid Python. All right, anyways. Cool. So let's find 30. Okay. All right. We're done with Python for now. We're just going to run. So who loves Python now? And that's fewer people. What the hell? Who loves IPython now that didn't love it before I showed all that? All right, we got one convert. That's good. All right, awesome. You have heard the good news of IPython. C. This is where, I don't know, people start suffering, but it's good. Okay, we're gonna zoom out. Can anyone still read this? All right, good. C. We're gonna perform a bunch of checks. We have like 20 lines of hints. That's how you know this is gonna be painful. The basic idea is your process must be your own program in your own home directory. You might say, yeah, but Jan, you already have execv.c, right? So of course we can just do this, right? Two things are about to happen. One thing that'll happen is that my shell, oh no, never mind. We just do this and it says, no, the process must be your own program in your own home directory, right? And that's annoying. Why is that annoying? It's annoying because there isn't enough outputs to tell me that my process right now is, oh no, there is, okay, good, phew. It looks at bash. Why is it looking at bash, even though I ran my execv program? Yes, because execv replaces the program that called execv. Execv is, that process gives its life for the new process. It doesn't birth a child. How do you birth a child? Fork. Fork. I wish it was simple enough that I could say fork is the only way to birth a child in Linux, but there's also clone. But it's basically, we'll get into that later. But So exec v is no good. So I'm instead going to do fork exec.c. Fork exec.c is a very beautiful, simple thing that's going to fork. This creates a child and a parent. The child and the parent, where my cursor is blinking, will be executing together, both of them as two separate processes that are identical in every single way, but one. Well, two. One is that the parent process of the original process is going to be my shell. The parent process of the child is going to be that process that called fork. Does that make sense? So a new process will be created that will be a child of the original process. What's going to be the second difference? Something that the next line I'm going to type will touch. Yes. The value of I in the parent is going to be the process ID of the child so that the parent can keep track of the child. The value of I in the child is going to be 0. So very easily we can say, hey, if I'm the child, it is time to exactly E the program. If I'm the parent, I'm not going to do anything. So what's going to happen here? I'll tell you what's going to happen here. I'm going to do fork exec. Okay. Null argument, well, not null required. It doesn't know what it's talking about. We can perfectly happily pass in null there. All right. So fork exec. It ran it. No good. And in fact, no good in a frustrating way. It says, hey, okay, now my parent is Docker init. What the heck is Docker init? Right? Docker init, if I look at all the processes running on my server, oh, we do have Node. Shit. We should have done Node for baby Suud. Anyways, okay, it's not important. If we look at all the processes running, Docker init is the first process, PID1, to launch in this container. When a parent process terminates and it still has children, that's very tragic. What happens is the children get adopted by the process that has the process ID of 1. There's a whole crazy thing about containerization in Linux that we won't get to right now, but the TLDR is that when a process terminates, all of its children get reparented to PID1. That's what happened to my child here, and that's why its parent was Docker init. Why did it happen? I'm still around, right? I was right here this whole time, right here doing nothing, and then immediately exiting and terminating, right? I wasn't there for my child. And we need to be there for the children with the wait PID call. How do we use this thing? Well, you can man wait PID, read a bunch of stuff, but since I've already done it, just going to tell you that you put the PID, you put a null, you can, if you put a pointer here to a valid structure, you can actually get the return code of the child and so forth, right? Which is useful information if you're actually doing software development and care about how programs terminate. And then this is some options like, if the child hasn't terminated, return immediately and let me know, stuff like that, but you don't need any options. So this will just wait for the child. And now, and we should, of course, normally I ignore these things, but because you don't actually have to declare things, C does its best with unknown functions. But if you, every once in a while, you run into a situation where you completely screw yourself over. So just include the things you're supposed to include. Wait PID is in sysway.h. It says so on the man page. I like to sort my includes in like a reverse length order, so it feels like you're sliding into the C code. It looks better if there's multiple includes. All right, anyways, run this guy. Boom. Okay, new thing. Must be called with no command line arguments. Whereas our argc is 1. Executable. Okay, but that's not very nice. All right. So if you're checking, that's on my parent. Okay, that's my bad. Is that on my parent? Yeah, that is my parent. So I ran the parent like this, right? Because I wanted to do something cool here. It's not gonna let me do that. Oops. It wants this to be that. All right. Now we run this. Okay. Final test. My program must contain a function named pwn.college. Why do we have this? Well, because otherwise you would just copy the shell into your home directory and get away with it. Okay. So we have pwn.college. Doesn't matter what it does. Doesn't have to do anything. I don't have to call it. I just have to have it there. Okay. Now I need to put in a password. All right. And here's the flag. Got the flag. Got the flag. Boom. Okay. Any questions on starting code in C? Launching other programs. Yes. Can we do level 50 and 60? 50 or 60. Yes, I can. Will we get there? Maybe. What is level 50 and 60? Is it like a Python and then C? Okay, for piping? Okay, yeah, let's skip ahead to 50 and 60 since we are, what time is it? I don't have a clock. Oh, I have a clock on my watch that I keep looking at. Anyways, all right. So remember, exec-v replaces the current process. Fork creates a new child, and you should wait on the children. Okay, awesome. Let's skip ahead to level 50 by popular demand. Let me catch up to Twitch. Jan, please. I wasn't there for my child. All right, there was a question, is this Hack the Box? This isn't Hack the Box. This is pwn.college. Pwn.college, as someone mentioned. Okay. And is it possible to go from no or very little experience and learn ground up? We're finding that out, aren't we? All right, so we launched, did I launch this already? Yes, awesome. By the way, Connor, this whole thing where I don't have to have stage back in, it's pretty good. All right, let's launch the challenge. Executable must be Python. Mine is Bash. Hey, no problem. Interactive IPython instance. That's how I like working, period, inside IPython. You know, I wrote my marriage proposal in IPython. No, I'm just kidding. That would be awesome, though. All right. So I launched this in IPython. Boom. Okay. Let's decode. Yeah. All right. So it says something broke. Let's. Does this work? Well, I'm guessing I'm missing some STD error. Let's push it. Okay, here's what we're going to do. We're going to go interactive here. Okay, awesome. For whatever reason, oh, I know what's going on. Okay, sorry. What is the problem here? Why didn't I get this error message? I did p.read, nothing came back. Well, when you do .read in Phone Tools, gives you whatever it has so far and just returns that, right? If I want to read everything, I do read all. Now, okay, std out of this subprocess does not appear to be a pipe. So I need to make std out a pipe somewhere to some program, right? So let's make it a pipe. How do I do that? Man, it's not bad in Phone Tools. So this is our pipe process. Let's do P2. P2 is the process. P1 is the challenge. P2 is the process we'll be piping to. Let's just do bin cat. Okay. Now, when we do bin cat, how do we cat the challenge into it? We just pass it in here. Done. Yes. Okay. This is a tail. It's a what's the term? Cautionary example of Phone Tools. Do you see this? I used a variable p that used to exist. That's no longer like being used in my current script, but of course, in the interactive session, it still exists. All of these things have had effect, and it's very easy to screw yourself over. So be careful with IPython. IPython is a double-edged sword, has many powerful things. All right, so I can do p1.readAll, and it doesn't work. Why doesn't it work? Because P1's standard out is P2. I can't just like jump in the middle between P1 and P2 and read out of P1. So I can do P2.readAll. And it doesn't work. Why doesn't it work? Well, now we can start getting at the power of Phone Tools. I can set up logging. It's log level, right? No. Log level, one word. No, it was log level, two words. Why didn't it? Okay, let's do that interactive. Oh, what's going wrong? There's a number of things. One is I'm a complete airhead. What's the term? Frazzle brain? What? I'm a complete noob, and I actually said std out is P2. P2 what? P2.std in. I want to hook up the output of my process with the input of cat. All right. This should now be good. So if you saw when I went into interactive mode with cat, I started typing, Phone tool started giving me debug messages. Hey, you sent this to cat. Hey, I received this from cat. I didn't want to see that because the challenge should have been sending and receiving stuff. So now we can do this. And boom, it flew. Okay, anyways, the executable can't be cat. It should be sed. All right, no problem. We just do user bin sed. Okay, and what did we get on standard error? We got a big riot act from sed saying, hey, you're not launching me correctly. This is no good. You're a terrible Unix programmer. Shouldn't be allowed to use the command line, and so forth. All right. So, of course, the goal of this was for you to look up the sedman page and learn how to use sed just a little bit. But what we're going to do is just search for all capital letters X and replace them with capital letter X. All right. Boom. Success. The executable on the other end was sed, and it printed out on the flag. Now, let's do something funny. Show you how sed works. If we do S here and we do X here, see, it replaced the letter S in success with an X. Very funny, sed. Oh, it might have screwed up my flag too. But there are no capital X's in there. Oh yeah, there's one. Okay, we're probably screwed. All right, yeah, so be careful with that. Anyway, sed is super useful as to a Linux sed. If you're like in Linux and you need to get something done, chances are sed is one of the combination of correct tools to do it. So learn sed. Be a sed head. All right, you take that, we paste it in, victory. All right, and it's 2 lines of Python, right, with pwn tools, and actually also with subprocess, the exact same, almost the exact same code, except for that very last line for reading stuff works. The nice thing is this phone context log level. You saw I got unconfused at one point because I was interacting with cat, and phone tool said, hey, you sent something to cat. I was like, oh, I shouldn't be sending stuff to cat. The challenge should be sending stuff to cat. All right, what was the other request, 60? All right, so I'm guessing 60 is that, but in C. All right, here's 60. So let's run it. Oops. All right, executable should be bin bash. Wait, what? Oh shit. All right. Did we launch? Okay. The baby suet is up. Let me just show you one thing, then I'll switch over and show you how to do 60. I'm sorry. I thought we had 45 more minutes. All right. If you go into challenges, go into program misuse. Program misuse is up. We already have, so holy shit, someone's making their way through it. All right. Level 1. We run it. Let's race whoever's going. All right. We're in level 1. Run baby suet level 1. Okay, it says I just set the suet bit on user bin cat. So you can read the flag. Okay, that was easy. You know how cat works. Okay, but do you know how more works? Well, it turns out more works very, very similar to cat. Okay, and the first 8 or so are basically freebies. We're just like, hey, look, there's also this that reads the last line, there's this that reads the first line, but there's only one line in that file, so it doesn't matter. But then if you go very far down and launch level 39, I don't have the numbers memorized, but you know, we'll see what this is. CP. Can you leak the flag with CP? Just copying it around. Can Connor do it? I don't know. All right. Cool. So that's baby suet. go forth and get flags. Good luck. Baby Suit is due in a week. I'm going to finish up level 60 for anyone that's interested, and then we'll go from there. And of course, if you have to leave, this will also be in the VOD when we upload it to YouTube. Cool. All right. Let's see, level 60 of program interaction. Level 60, level 60, level 60. Boom. What? Oh. Oh, there's a question on Twitch. How do I prevent having to SSH in every time? It's automatic now. If you SSH in rather than use the web interface, when you restart the challenge, it'll automatically drop you into the correct container. All right. So let's take a look. What are we doing? We are figuring out how to what we're running with this challenge. All right. Process must be my own program, my own home directory. I did this already. That's our fork exec. And let's change it to level 60 instead of level 30. All right. You should have redirected. Of course, it's the same thing, right? Does not appear to be a pipe. Now, how do we make this pipe happen? Now it's harder. As a preview, we're going to need to fork twice. And fork exec. All right. So we have a parent that needs to remain this program. And we have a child. Man, what the heck? The person that asked for this left. It's fine. It'll be on YouTube forever. Okay. We have a parent that needs to stay around, and we have a child that needs to pipe the output of this program into SED. So we'll need to have the child, we're going to have the parent, and then it'll have two children. One will be SED, one will be the challenge. That means we'll need 3 processes total. That means either the parent or the child has to fork again. We're gonna, it's easier for me in my head if the child forks again. So we're gonna have the child fork, and then one side will launch SED, and one side will launch the challenge. It doesn't matter which one. So here we go. I'm sorry. Oh, you think level 60 is cat? Okay, cat it is. I'll believe you. User bin cat. All right. Boom. All good. Perfect. Now we compile this. Okay. And we run it, and it still complains. Which makes sense. Why does it make sense? Because there are 2 reasons. One is cat goes nuts if you pass it a null argv0, or many different utilities go nuts. Don't do it. If you don't want to set up the necessary structures for an environment variable, and you will need to do that in other levels that require specific environment variables, you can use exec L that will just let you specify the path, the argv0, the argv1, and so forth. So this will cleanly launch cat. Okay. All right. Now, of course, why are we hanging? Well, cat is holding us open. Why is cat holding us open? Hey, guess what? We didn't redirect anything anywhere. We just launched cat. Okay. So, excuse me, it's similar to what we started with in the Python case. Well, let's start redirecting stuff. Of course, it's not as easy as in Python. Python makes life easy. Life without Python is hard. Unless you're using x86 assembly, then it's hard, but rewarding. All right, but it turns out it's actually pretty easy. We have our pipe file descriptors that we can create ahead of time. It doesn't get automatically created using the pipe system call. How does this work? Man pipe. Nice and easy. All right. So we have the pipe system call. Sorry, my throat is dead from talking apparently for almost 2 hours or over 2 hours. All right. We created our pipe. Now the pipe has been created. Now, what? Did someone say something? No, okay, good. The pipe has been created. Now we have to, of course, actually say, hey, the standard input of cat is going to be one side of the pipe. The standard output of the process is going to be the other. So we use dupe2 for that. We take the right side of the pipe, the side of the pipe that you write into. It's also the right side, which is, if you look left to right, it's the second pipe, the second entry in that 2-entry array. And we'll say, hey, that's going to become the new standard output of this entire process. And of course, very shortly, that entire process is going to be replaced with the challenge, and it'll become the challenge standard out. This exec VE will cause this new process to inherit all the file descriptors by default of the parent process. And here we do the same thing, but we do the read side of the pipe into cat's standard in. All right, now we run too few arguments to the, oops, this is in Python. So we create this pipes and then we pass that into the pipe. There we go. That's how you do things in C, nice and painful. Okay, run fork exec, and it hangs. What the hell is going on now? Well, I will tell you what's going on. Cat is still sitting around reading, and it's still sitting around reading because it itself still has the right side of the pipe open. And that just causes big havoc when multiple things have the right side of the pipe open. So make sure to clean up after yourself and close things when you don't need them. So this closes the right side of the pipe when we execute cat. Because cat doesn't need to write to it, but its existence is keeping that pipe open when the challenge process terminates. The same way, we should close the read side of the pipe here, just to be good pipe citizens. Now, of course, this and this, that code is running in 2 different processes, right? And I'm gonna run this and then show you what else is wrong that I just noticed. All right, now we should be almost set. We run it, broken pipe. That's no good. That means our pipes are fucked up, messed up. How are our pipes messed up? Do you remember what happens after fork? We have 2 processes executing, and this code gets run in both processes, and we don't want that. The 2 processes, the grandchild and the child, they're creating 2 different pipe pairs. That's very bad. That means we're not actually combining them with the same pipe. This pipe needs to be created before we fork. For ease of life, unless you know what you're doing, always check for the return value of the fork immediately after forking. The very next line. I guarantee you, if you don't do that 99 out of 100 times, you introduce insane issues that take ages to debug. All right, we run it, and there's still something going on. The parent executable is cat. God damn it. All right, we screwed up because the grandchild is running. This is the grandchild where the second fork returns to 0. And of course, its parent is the child, which replaces itself with cat. So now the parent of the grandchild, which is the challenge, is cat, which is not what we want. So we can just simply flip this. We have the child executing the challenge, the grandchild executing cat. Oops. My iPad's about to run out of batteries, but that's okay. It'll last just long enough. All right. Here we go. Boom. All right. Thank you. Thank you very much. So that's how you do level 60. And of course, this is less than halfway. Things just get more and more insane from there. Remember, the checks are done on the parent process, et cetera, but the parent process can have other children. So if you need to, from C, launch a Python program to talk with the pipes, you can do that. Nothing's preventing you. They can't arrest you for it. All right. Thank you very much. I'll be here for a couple of minutes to answer any questions, and then otherwise, good luck on the homework. See you next week. Oh, wait, is it Tuesday? See you on Thursday. Remember, assignments due in 1 week, but I'll remind you of that on Thursday. Thank you for joining us online. Good luck. Connor, what's your experience?